Good afternoon, everyone. My name is Dale Brosius. I'm the Chief Commercialization Officer and Executive VP of IACMI, and welcome to the November edition of Innovation Insights. Glad, if you haven't joined us before, I think you're in for a treat today with three great presentations. But before I start that, just remind everyone the three C's of IACMI: convene, connect, and catalyze. Surrounded by a cadre of things like networking, education, facilities, interns. You'll hear about interns today, opportunities for co-funding and getting involved in working groups, among other things. So if you're not a member, this is where you go, start the process there, and we will walk you through it. If you want to have more dialogue on that about becoming a member, start there, and we will entertain that as well. Just a reminder is this webinar is being recorded, and every previous webinar is on the IACMI website. 34 episodes since May of 2021, almost closing in on 100 members and partners of IACMI presenting in this. And so you can go there and catch up on anything that you may have missed. If you see something today that you really want to pass on to a colleague, you'll get a link to the recording in the next couple of days, and then you'll be able to send that on to them. We've already got December is lined up. December's Innovation Insights will be Monday, December 16th at noon Eastern Time with Temper Inc., Thermomatrix, and Cabium. And you might go, well, who are those folks? We'll show up and you'll learn a lot more about them, about these innovative companies that are members of IACMI. But for today, we've got three presentations teed up, including Crown Composites, James Cropper, and our own Amy Kiesler to talk about our intern program. So I want to make sure they get the floor most of the time. So I'm going to turn it over to them. So we're going to, Kim, I think I'm going to turn over to Gary Ellerhorst, who is the president of Crown Plastics, and believe we start with a recorded presentation, then Gary will be available for answering questions.
Yes, thanks.
Okay.
Right, I just need a second to. Bill, could you please stop sharing?
Trying to get there.
Okay.
It's not wanting to do that for me.
Well, sometimes it's fussy. Let me see if it'll let me go. Can you see the Crown Plastics presentation on the screen now?
Sorry, I finally was able to get to the stuff.
Ellerhorst, President and CEO of Crown Plastics. Crown Plastics emerged in 1973 with the dreams of my father, Robert Ellerhorst, and the equipment, patents, and rights to develop continuous compression molding technology for ultra-high molecular weight polyethylene. Through the intervening decades, the company continued to seek new opportunities, including entering the snowboard market as a supplier of sintered base material, where we now control 90% of the U.S. sintered snowboard market. Crown Plastics sells our products to both recreational and industrial markets. And while we continually seek new applications for our products, we have also expanded our reach globally, actively pursuing customers in Asia, Europe, and Latin America. In 2008, we expanded our manufacturing footprint with a wholly owned facility in Xiamen, China. For industrial applications, we have placed special emphasis on material handling with our DuraSurf STS product for conveyor beds and package handling chutes. We also serve the transportation industry with specialty products designed to eliminate buzz, squeak, and rattle, and noise, vibration, and harshness issues in the automotive industry, and abrasion pads and cushioning assemblies that reduce vibration and wear between the rail and concrete ties in the commercial and passenger rail industry. Today, we are the world leader in the manufacture of thin gauge UHMW PE. As Crown Plastics has grown in physical size, we have at the same time developed a culture to empower our customers, suppliers, and employees to work together to find new and exciting high-value applications for our products and processes. Over the years, we have participated in the area of thermoplastic composites, offering contract debulking and lamination services. The composite market is a fast-growing market with established end uses that currently utilize other than composite materials. Today's use of composite materials is currently estimated to be in excess of $7 billion, with an estimated 7% compound annual growth rate. The opportunity for replacing traditional use of metals makes the market potential many times greater. Driving growth are such factors as the need for strong, lightweight materials in aerospace design, new, safe, fuel-efficient designs for rail and automotive transportation, the search for alternative materials in the development of renewable energy, new science developments in medical and prosthetic applications, and increasing need for protective, lightweight body and vehicle armor. We would like to share with you in greater detail our unique manufacturing capability and examples of composites in development and production.
I am Mark Roeder, Director of Product and Application Development here at Crown Plastics. Thermoplastic composites are manufactured using thermoplastic polymer matrix reinforced with glass, carbon, aramid, or metal fibers. Thermoplastic polymers are long-chain polymers that can be either amorphous or semicrystalline in structure. These long-chain, medium to high molecular weight polymers make thermoplastics that are tough, resistant to chemical attack, and have a long shelf life. Crown Composites' unique manufacturing advantage is its ability to create composite materials via long, continuous compression runs at high temperatures and pressures. With processing widths up to 24 inches and the ability for 60-inch wide production, Crown Composites' production system is capable of handling both small-scale and full-width prototypes, all within the same system. Crown's composite technology allows for the unwind of multi-layer woven and non-woven thermoplastic materials. The ability exists to add thermoplastic resin layer with a variety of fiber additives. Delivery options include sheeting capability and wind-up rolls. The unique process is basically two endless stainless alloy belts that heats, compresses, and cools in a continuous fashion. This process has the ability to achieve up to 1,500 psi of isochoric molding pressure with a maximum temperature of 750 degrees Fahrenheit. This high pressure, high temperature capability allows for the processing of high temperature engineering polymers like PEEK, PPS, Ultem, nylon, and fluoropolymers. Thickness possibilities range from 0.010 of an inch thick for thin film composites up to over 1.5 inches for surface lamination of honeycomb and other core materials. Over the years, Crown Plastics has participated very heavily in the debulking and consolidation of nonwovens. This is an Ultem and glass material that has been debulked to this thickness from 2 millimeters to about 1. Here we have a PPS nonwoven in roll form that has been debulked to 0.5 millimeters. This is a nonwoven from 10 millimeters down to about 1 millimeter. The debulking of nonwoven materials is used very heavily in the aerospace industry for interior panels that Crown debulks and will later be thermoformed. Another advantage is that with Crown Plastics as an intermediate process to other molding processes, you can achieve increased density and very laminar structure. An additional advantage for Crown Plastics debulking the nonwoven materials is to reduce transportation costs and reduce storage area required at the end user. Crown Composites' unique technology has the ability to apply surface skins to thermoplastic honeycomb. Typical thermoplastic honeycomb applications include, in the transportation, aerospace, recreational vehicles, and high-speed rail. Composites has successfully encapsulated lightweight copper and aluminum mesh to form shielding materials for applications requiring electromagnetic and radio frequency interference control. Applications include the aerospace, automotive, consumer electronics, and the defense industry. There is an ever-increasing need to remove weight while providing ballistic protection for personal body armor and other light armor applications. Crown Composites' ability to work with glass, carbon, aramid, and nanofibers allows multi-layer materials to be efficiently and cost-effectively formed utilizing our unique continuous process. We have also successfully encapsulated silicon carbide, ceramic, and steel tiles to form durable strength armor plates. Crown Composites manufacturing capability allows us to provide multi-layer materials with armor quality fibers to produce ballistic panels for use in military shelters, light vehicle and aircraft armor, and commercial applications such as financial institutions where personal protection is desired. Crown's composite processing system allows for easy setup and changes from one production run to another. Our system also allows us to accept small orders to large-scale production runs, as well as prototyping requests and pilot runs. In fact, we can provide prototype products with sample materials as small as letterhead size sample sheets. Crown's system also allows for preheating of material and post-curing and processing. In summary, Crown's composite technology offers you continuous multi-layer capability for manufacturing new composite products utilizing a variety of woven, non-woven, and resin molded materials. Improved tolerance and density of material versus common batch processes. A unique continuous process that offers cost efficiency versus batch process. Trial efficiency with hand sheet and full width sample capability with minimal setup. For more information on our wide range of advanced thermoplastic solutions, visit our websites at crownplastics.com and crowncomposites.com or call us at 513-367-0238. Thank you.
All right. Thanks for that video. And Gary, I see you're on. So
yes, sir.
Is there anything you want to just say before we get into any kind of questions?
Yeah. I know there was some. It was some things were a little elementary from sure some of the viewers and things, but I guess what we're trying to is to show is the tremendous breadth of product that we can run, and we really have been focusing on from hand samples and just very early on development all the way up to recently we've invested a lot of money into our 60-inch press so that we can do actual production runs and are looking to further invest in this area. So we joined IACMI and we wanted to, like I said, we've been doing it for almost 40 years now. We have a technology, but there are countless people who, material specialists, application specialists, who we have just been trying to reach out to. You all know what materials you need, application requirements, but if we want to provide a means of from just basic idea, just to test feasibility studies up to small production runs, and eventually to offer production. We are not materials people. We do not want to be materials people, but we do have it is a unique process. There are other belt presses out there, but ours are still very different, very user-friendly, very quick changes. So it's perfect for development. We're right here located in the Midwest, right outside Cincinnati, Ohio. And so we really appreciate the offer from IACMI to come on and kind of share what it is that we look to do. We are very interested in working with any companies that are looking to develop and do small production runs and eventually grow into larger production. We understand that the constraint being taking very successful small batch production and scaling it. That is kind of really where we are looking to be within the all process. We can do it on a toll basis or are willing to. Sometimes we'll purchase materials and just process and sell to the material manufacturer's customer directly. However the customer would like us to handle the relationship. So I'll open it up to questions. I've got Mark Roeder, the gentleman who was on, is with me right now. Chris McClintock and Bill Morgan are here. And if anyone has any questions, please feel free, fire away.
Okay, well, there is a question that came in via the chat and asking if you'd be able to list a few recent automotive programs in which parts that use the product or use your products.
Well, right now, most of the automotive stuff that we have been doing is in the UHMW part of the business with our basically noise reduction, buzz, creak, rattle, replacing flock in a lot of areas where there are noise abatement, and the UHMW is far more abrasive and it'll last far longer. We have had other applications.
We can't listen because they're NDAs.
Yeah, NDAs, but anytime you've got sliding components, door components, anywhere you've got, but they almost all have been wear and noise related. We have not gotten to a point, we don't have the, until recently, until we had the 60-inch width, we have not really had the volume capabilities to produce a current automotive composite kind of product, unless it's a small part or component. But they certainly have been involved with companies in developing various test materials for applications in the transportation, the rail, and the automotive market.
Okay. The question for you is, yeah, I know a lot of what you do is based upon nonwovens, but what about, have you done work in multi-axial fabrics? Or impregnated multi-axial fabrics, continuous fibers, or semi-unidirectional materials?
Let Mark Roeder.
We have done some unidirectional and some cross-axis, but not very much. Only on developmental basis for testing only.
Okay. Do you think you would be able to do those forms? Continuous fiber forms?
Provided that they're in a roll, or if we're just feeding it a blank, yes, absolutely.
Okay. So what I'm going to encourage people to do, for in the interest of time, is that put your questions in the chat or in the Q&A panel, and we will hold on. There are questions in the. There we go. Okay, you already asked about continuous fiber or shortcut. Somebody asked about, so I think you've answered that one. And then can you tell us more about the EMI RFI shielding products you mentioned?
Again, we're limited on some things that we can say. There have been, they're being tested for use in I guess in field for radio frequency shelters, cabanas, things that they use. We don't have a whole lot of, we've got feedback as far as how well they tend to shield, but we have not developed far enough in an application currently with someone that's actually using. We're still in the developmental and testing on various materials that we're still in an ongoing process with at this point.
Are you still developing data on the shielding capabilities?
Yeah, yes, there, and also shielding in like around components in aircraft to kind of electronically shield, but we do not have a whole lot of final data yet.
Okay. All right. Well, thanks, Gary, and the Crown team. Again, if folks have questions, they can continue to post those, and we will move on to Caleb Fields and Mark James. Caleb's a technical sales rep, and Mark James is a research specialist with James Cropper Corporation. They're members of IACMI as well, and I think We're going to be talking a little bit about EMI shielding. So you're
Thanks, Dale.
Caleb, you're up, and we see your slides. So take it away.
Wonderful. Thanks, Dale and the IACMI team. So as Dale said, we are going to be presenting on novel functions of lightweight conductive nonwoven materials in composites. My name is Caleb Fields. I'm in technical sales for James Cropper, focusing on the composite industry. I'll be presenting with Dr. Mark James, who is a research specialist on our technical team with expertise in conductive nonwovens. He actually just mentioned to me that there is a fire drill at the facility that he's at. That was like 2 minutes ago. So we'll see if he makes it back for his part of the presentation. If not, I may cover for him there. So getting into it, we are James Cropper. So some of you may know us by our former name of Technical Fiber Products. So we have always been part of James Cropper, and we changed our name from Technical Fiber Products to James Cropper this past July, basically to unify the entire company under one global vision. Some of us, so for those folks out there who knew us for our nonwoven solutions, which can be found in anything from hockey sticks to automobiles to aviation, the greater James Cropper company also has expertise in electrochemical coatings, specifically for the hydrogen industry, as well as creative papers and luxury packaging, including our award-winning molded fiber packaging technology. So our materials really are all around us. From the advanced materials side of things, we are leaders in advanced materials. We're able to create custom materials for specific applications. We work quite a bit in composites as well as the hydrogen industry and others. So we are a global company. We are located in England. That's where our headquarters is. We are on the London Stock Exchange, and we also have a US manufacturing location in Schenectady, New York, which is just outside of Albany. In Schenectady, we do metal coating of carbon fiber tow, which we'll go into in a little bit. And we also do electrochemical coatings there as well. Most of our nonwovens are made in the UK. We also have fire protection materials that can be integrated into composites. We do particle plating, nano coating, specifically to add conductive carbon nanotubes into our materials. So we have a wide range of expertise in advanced materials. So to start, I'll kind of go into what is a nonwoven. So for those folks in the composite industry, you might have heard the term veil or scrim or mat or paper. These are synonyms for nonwovens. Our manufacturing process in particular is a wet laid manufacturing process. So we are taking short chopped engineered fibers, 6 to 12 millimeters in length, and some type of binder system to keep those fibers together. And we are laying them down similar to a paper making process. So what's unique about our materials is that they are designed for composites. They are extremely lightweight. We can go down to 2 grams per meter squared. Typically, we work in the 2 to 200 GSM range. What's unique about our process as well is that it provides a very uniform aerial weight and thickness, as well as a uniform fiber distribution. So when you're putting it into a composite layup, it's common with all resins and manufacturing techniques, all common resins and manufacturing techniques, including thermoplastics and thermosets. And it's very highly porous, so it wets out very, very well. You know, one other thing that allows our company to stand out is that we have high volume manufacturing, but we also have the ability to create unique custom solutions for specific requirements. So if an off-the-shelf product doesn't work, we likely can develop one that does work for your application. So from a manufacturing perspective, we have 4 manufacturing lines. We manufacture in roll form up to about 2.1 meters wide, which for the Americans is about 82 inches wide. We have the capacity to manufacture tens of millions of square meters of nonwoven a year, but we also have a pilot line that we can do development work on and create custom solutions for market-driven or specific customers. We also have extensive converting capabilities, so we can slit down to about any width you need. We have lamination and powder scatter, as well as nano coating capabilities. And at our Schenectady facility, we have 2 different metal coating lines. So going into our conductive materials here, we take carbon fiber tow and use either an electrolysis or an electrolytic coating method and coat the carbon fiber tow with various metals, typically copper and nickel, or copper and nickel. And we then turn that into a non-woven material. So for folks working in composites, our materials, specifically the non-wovens, are typically providing a non-structural function to the composite layup. So within composites, those can be used as carriers, typically for an adhesive. Most commercial airplanes have our materials on them as an adhesive carrier. We also work quite extensively in improving the surface finish of composites, as well as the abrasion resistance, fracture toughness in carbon epoxy composites, fire protection, and we're also working in sustainable and recycled materials such as jute and PA11s as well. So within conductives, which is the focus of this presentation, we provide very lightweight EMI shielding solutions, as well as resistive heating, static dissipation, and corrosion resistance, which would be a dielectric material for corrosion resistance. So when we're talking conductive materials, the main materials that we are working with are carbon, blends of carbon and other materials to create specific electrical properties, as well as our metal coated carbon materials. And recently we started working in silver coated nylons as well. So I'll turn it over to Mark. I'm not sure if he's here or not due to the fire alarm. Are you here, Mark?
Just returned, Caleb. Sorry
Perfect.
about that. That was exciting. So my name is Mark James, and I'm just going to briefly summarize some of the benefits of using our conductive nonwovens. On this slide, I've basically just shown at the top the range of resistivity of metals to base polymers, spanning nearly 21 orders of magnitude. The resistivity range covered by our nonwovens is highlighted by the double-headed yellow arrows. On the left would be our metal-coated carbon veils, and on the right would be our dielectric veils made of glass or polymers. And the central portion is covered by blending a fiber mix of our conductive and dielectric fibers. Even a small coating of the metal on the carbon fiber enhances the conductivity significantly. And on the next slide, I'll just cover that a little bit more. Here we have 2 graphs that summarize some of the key benefits of our non-woven veils. On the left, the enhancement a metal coating delivers to the EMI performance of a carbon non-woven is really, really clear. We have shielding data that's from about 100 megahertz up to about 40 gigahertz. And on this graph, we're just going up to about 1.6 gigahertz. But as an example, if we take a 34-gram carbon veil, the shielding effectiveness is around about 45 dB, which is really, really good. However, if we apply a thin film of metal to the fiber, this enhances the shielding performance to around about 60 or 65 decibels, showing the improvements that can be gained by just coating our materials with a little bit of metal. On the right, we have a graph that shows the coefficient of linear expansion of certain materials. And the core benefit of using a non-woven fiber platform is that the coefficient of thermal expansion of the core fibers is similar to the coefficient of thermal expansion within the fibers within the composite. Our customers like this aspect as it reduces the repeat stress due to thermal loading. With that little summary, I'm just going to talk a little bit more about the electrical conductivity of our materials on the next slide. As we discussed, coating a minimum metal onto the surface of the carbon fibers can enhance the conductivity of the nonwoven by about an order of magnitude or more. And the metal coated carbon nonwovens are a great choice if conductivity of the composite part needs to be enhanced. The level of conductivity can be tuned by varying the weight of the nonwoven, which is a massive benefit. There are also applications that benefit from a slightly more resistive material, such as resistive heating. And the inherent conductivity of the carbon fiber provides an excellent platform to manufacture materials with higher resistance values. Incorporating conductive and dielectric fibers together in JCM's nonwoven technology provides a platform to customize the resistive properties of fiber veils. And blending of carbon and dielectric fibers allows the resistance values to be adapted to suit your application. The isotropic nature of the fibers in our nonwoven technology provides a blanket of even heat distribution, minimizing hotspots. And the pore structure gives a format that is readily infused by resin for simple incorporation into your composite application. Now, we've discussed a little bit about conductivity, but that conductivity also enhances the EMI performance. So on the next slide, we'll just discuss that a little bit more. The benefits of applying a conductive coating onto the carbon fiber gives another non-woven platform to build tailored EMI solutions. The non-woven provides a network of highly conductive fibers that are surface covering while giving a uniform distribution of pores. And that porosity structure between the fiber facilitates resin infusion for simple integration in your composite part. Precise control of the non-woven weight allows the shielding performance to be tailored for your application. And the low weight solutions give weight savings while still delivering on shielding performance. Isotropic arrangement of the fibers give an even reflection profile for your composite application. Now we just touched upon the conductive properties of the veil. And we're going to move on to a little bit onto the dielectric veils and the advantages that these give within a composite. Particularly, we're going to talk about corrosion resistance. And JCM's dielectric nonwovens provide a platform to build galvanic barriers within a composite structure. For example, where you have carbon and aluminium within the same structure, we want to separate those to prevent galvanic corrosion between the two. The dielectric fibers in a non-woven format provide a structure to do that by separating out those two materials from each other using a tailored thickness and weight. The open structure allows a dielectric resin to fill the voids to form the galvanic barrier region. The isotropic arrangement again reduces stress within the composite parts, and fibers have a comparable thermal expansion to other composites materials, reducing stress. Having briefly discussed some of the properties of our materials, I'm going to pass back to Caleb for some application examples.
Thanks, Mark, for your expertise there. So I'm just going to run through a few case studies that show how our materials are used in these various applications. So as Mark mentioned previously, we can do blends of various materials to fine-tune the electric properties to a specific application. So both of these case studies here are examples of that. So with resistive heating, one challenge in aviation is de-icing of plane wings. So the standard way of de-icing a plane wing is to put harsh chemicals on it, which also acts as a secondary step because you have labor involved in doing that repeatedly. So a customer of ours was looking for a solution where they could actively de-ice a plane wing. So we developed a blend of glass and carbon that had the specific resistance that they need for their resistive heating setup. So our material was in the composite plane wing, connected with either a bus bar or a conductive adhesive, and a current was run across it. And it provided active uniform heating of the wing surface for de-icing applications. And compared to a copper wire solution, our materials will provide a more uniform heating of the surface because they are very uniform and cover the entire surface instead of just kind of going up and down like a copper wire would. So moving over to another blend of materials, this would also be a blend of glass and carbon fiber. We have a customer making composite industrial rollers for the paper making industry. So these rollers, if you imagine a composite spinning very quickly, they build up static electricity. So they needed a small amount of conductivity on the surface of the roller to expel the static charge to the ground. So we developed a glass carbon blend, very lightweight at 17 grams per meter squared, that allows the static electricity to be dispelled to the ground and reduces shock and fire hazards in the industrial setting. So another application, as Mark mentioned, is EMI shielding, and our lightweight metal coated materials have been used extensively for EMI shielding, both in avionics enclosures actively, as well as in EMI shielding for battery boxes, both in aviation as well as automotive. So we had a customer who was looking for a lightweight shielding solution for a battery box on an electric plane. And current EMI shielding solutions are typically aluminum foil or conductive coatings. Both of these are added after the composite part is made, so it requires a secondary step. And since they're on the surface of the composite, they're less durable, so they can be torn if they're in contact with something that's abrasive. So what we did is we developed a solution that's a lightweight 30 gram per meter squared carbon that's coated with copper and nickel. And we got similar EMI shielding to the aluminum foil solution, but our material reduces that secondary step because it goes directly into the composite layout. So it's a more elegant solution, and it's more durable as well because it's in the composite rather than on top of it. So the final example I use here, as Mark mentioned, we have dielectric materials. Often galvanic corrosion is an issue, especially in aerospace when you have aluminum parts being bonded to carbon fiber parts. That's very prone to galvanic corrosion. So you need a lightweight solution because it's on an airplane, and you still need it to protect the aluminum from interacting with the carbon. So our 20 gram glass veil was used as a lightweight dielectric barrier to extend the life of the part and prevent galvanic corrosion. So thank you very much for listening, and we are open to any questions and very willing to send you this presentation afterwards if you like.
Thanks, Caleb and Mark. Yeah, I saw some very lightweight solutions that you had there. What's the range of fiber aerial weight that you typically have? Or you
So the lightest,
from lightest to maybe even heaviest.
Yeah, the lightest is 2 grams per meter squared. We can do that with a carbon, which is only about like 3 carbon fibers thick. So it's very, very lightweight. Typically, customers are using in the 4 to about 75 GSM range, but we can go up to 200 and sometimes a bit higher depending on the application.
Okay. So does the EMI shielding non-woven on the battery boxes, does it tear at high elongation areas like corners during molding? It depends on how you.
Yeah, so it's going to depend on the manufacturing method. We have materials that are developed for specific manufacturing methods. For instance, we've been working the last couple of years on a project to integrate our EMI shielding materials into the SMC process, which and our solution allows the materials to flow in the SMC rather than tear, where typically a non-woven would tear. So other than that, it would come down to the specifics of the manufacturing process, but typically our materials are compatible with most manufacturing processes, and we rarely see issues like that.
Okay. In a molding application, say compression molding, what do you think what's more or less the highest fiber volume that you can attain?
So I don't have that answer for you. So typically people are using our materials as non-structural materials. They're using it for the function. So they're less concerned about the fiber volume because it's non-structural, and they're more concerned about the level of EMI shielding or, the resistivity or whatever function it is.
Okay. All right. I appreciate it. We're at 12:40, and so we'll move on to our next presentation. I see emails are up there, but if you'll stop sharing, we'll let Miss Amy Kiesler come on and share her screen. But if you still have questions, you can put them into the chat. If you want a copy of the presentation, make sure you put that in the chat or send a direct question to Kim Hooden, and we will get you a copy of that. So thanks again, Caleb. And Amy, you need to unmute yourself and Amy, you're on. There you are.
Thank you, Dale. And thanks for
Okay.
inviting me today. I actually have to say that I've enjoyed going back to the YouTube channel and learning about our members through the Insight program. And so I'm pleased today to be able to inform a little bit about the intern program 2.0. So as Dale said, I'm Amy Kiesler. I'm the Education and Workforce Manager here at IACMI. And I feel like to fully understand interns 2.0, we have to appreciate all of the first round of amazing outcomes that the intern program has. As you can see from just the small amount of people that are listed here, 100% of the interns either got a graduate program offer or an offer to work immediately in the industry. So this has a history of excellence as we're entering into the program. Thankfully, I was able to announce in June at our members meeting all about the intern 2.0 coming and what the outline kind of was for us, with October 1st being that date that we hoped to relaunch the program. Well, October 1st came. It was a big day. And I have to say thanks to our friends in the communications department, friends who had previously had interns with us. The word was spread on our website, through newsletters and LinkedIn, and then, of course, reposting from people who had experienced the 1.0. And I'd like to stop there and make a plug. If you haven't done that and you are involved or were involved with the intern program in the past, we would appreciate any kind of advertisement that you would be willing to give for us. Since the members meeting, we have had much more behind the scenes work, and I wanted to put a face to a name. If you've been interacting with the interns at all, this is Petey. Petey Roach is our new Education and Workforce Development Coordinator, and she has been working hard behind the scenes, reaching out to campus centers and different members to help our program flow smoothly. She's been making sure that references are checked and that students are contacted about their preferences, and you're going to see her a lot more. So I wanted to make sure that you got to know her and appreciate the work that she's doing. One of the outlets that PD and I have realized is a big outlet that universities and colleges use is the Handshake website. So we have a link on the Handshake website. So if that's something like a college is announcing to you, yes, we are on the Handshake website, just in case they don't know about us in the IACMI world. And as you'll notice, a staggering amount of students and alumni are being advertised this opportunity through over 800 schools nationwide. I'd also like to thank people like the ABE community reaching out specifically to the HBCUs, appreciating the opportunity at SAGNAS to be able to speak with Native American students. PD has special connections in the Indigenous community. A coworker like Mary Ann's able to go to her local recruitment colleges. As you can see, getting 2.0 started really has been a joint effort from everybody in IACMI. So who can apply? Well, we tried to make it easy for students to be able to apply as long as they're a U.S. citizen and getting basically that they have a good undergraduate or graduate standing. They're pretty much able to apply because we wanted to leave more of the specifics to the host organization. So if you know of someone in your company, children, nieces, nephews, those kind of things that would like to apply, it really is an easy application. One of the differences in intern program for the 2.0 round is the fact that we're having a little difference in opportunities, more flexibility, really. We talked to different professors, we talked to different industry members, and they said, you know, with a summer intern, they just get familiar with the routines and research or the program, and we'd like to have them a little bit longer. So we're trying to have some flexibility by offering semester interns as well, and even further flexibility because we know that we live in a virtual world. There may be some remote students who would like to work part-time during the semester or aren't able to give up a full semester to be able to have that full-time role. So we've tried to be very accommodating to the possibilities, and also by taking out a third person and just working specifically with me or with Petey to be able to extend interns to maybe 2 consecutive placements if that is something that's needed. I wanted to put in here what the benefits are, but I really feel like they speak for themselves. And if you speak to anybody that's ever been an intern, I think that's the most impactful statement that you can hear, because they are so quick to tell you how everything that they learned in the classroom actually came alive when they were in the field, and that they could have never gained the knowledge that they had outside in the book world, but they gained those kind of things inside the field. So for you, it's developing that pipeline for your future workers. It's giving you assistance. And since we're vetting those applications for you, you're getting a choice of great students to come and work with you. And of course, please notice at the end that attractive cost sharing ratio that we're offering. So how do you become a host organization? Well, obviously you have to be a member. So I'll put that plug in as well. Our friend Kim Hooden, who's membership chair and also working diligently to help us get more interns, would be happy to help you become a member and refer you to Dale to talk to us. But if you are a member, really, you just have to have the ability to hire an intern as one of your employees, and we will give you reimbursement from the money that we've been given from the Department of Energy. And we would like one person to kind of be our communications point. That way they can be the person that we are speaking to throughout the duration of the time, finding out, you know, if we need to help with anything, how our intern is doing. And of course, I know that you'll have a mentor for that intern while they're there. So I talked about the fabulous cost share, and here it is. So in order to be congruent with our member dues, the reimbursement percentage is staggered by the size of the company, just like we have. And if you'll notice that bottom line of how much we're able to reimburse, I think that you can see that this is definitely a win for all members. When we break this down, you'll notice that we'll reimburse for things like the difference between a graduate and an undergraduate's hourly wage. If they need travel, if we find somebody in another part of the country who is coming to you, and then they would need housing while they're staying there. And one of the requirements that we're asking of the students is to have a poster session during our IACMI member meeting. And one other perk, when you think you're a member, just think you're getting free advertisement at the member meeting from those students who are representing what they've learned or what they have gleaned from your company. So how easy do we make it for you? Very easy. Go to our website, IACMI.org, and you'll click on the Workforce tab. It'll pull a drop down to you for the internship button. And if you'll just click on that, the internship page will appear for you. And if you'd like to scroll down, there are 2 links easily, and we listed both of them there just because in case you do know someone who'd like to be an intern, but you'll notice that it's just a click and the details come directly to us. We'll follow up with you with applications. We'll follow up with you in some cases. We have people who they've already maybe vetted some interns in their area and they just would like us to talk about the financials. And so we will let you easily apply to that. I wanted to say though, but please be patient. We've made a rubric to make sure that we're equitable to all of our hosts. In other words, we're not going to just give interns to certain companies over and over. We would like to spread the wealth and spread the interns, spread the future workforce. So maybe you won't get an intern in the spring, but you will get one in the summer or the fall. And if you have any questions, I hope that you'll contact Petey or myself so that you'll be able to ask us about any of that. So I'm going to leave you with a quote from Yates. It says that he said, education's not just filling up a pail, but it's lighting a fire. And I think with the interns, you'll light a fire for the future in composites. And I really appreciate you listening today. Are there any questions?
Thank you, Amy. Well, we had one here that, that I think is probably from somebody who's not a member that's interested in becoming a member, and maybe you're
Perfect.
Maybe your presentation sparked that. But other than that, I don't see any specific questions. I will just ask the question: is how's it coming so far? Given that we're closing in on the first semester of having applicants as well as on both sides.
Yes. Well,
companies and interns.
We're very excited because we had several applications that came out on that first day of October 1st, just because we were so excited about the relaunch, and then things began to slowly trickle in. But once we got on Handshake, we shot up. I checked this morning. I think we have over 500 applications of students who are waiting to have a place that's filled. We have members that have talked to us from the moment that I spoke at the members meeting all the way through. And we're already going to place the quota of what we thought that we were going to be able to place for this semester. And at this time, the good news is I think we have more than enough. And so we definitely will be spreading the wealth out through the summer and the fall as well.
Okay, excellent. All right. So I want to thank all of our speakers today from Crown Plastics, from James Cropper, and from IACMI, and for another successful Innovation Insights. Just a reminder, the next Innovation Insights will be on Monday, the 16th of December, and we'll roll into into 2025 after that, and you'll see as we get rolling again in January with that. So be sure to join us on the 16th of December before the Christmas holidays start, and we'll see you then. Thank you very much. Have a great afternoon and great rest of your week.